All right, we're going to go ahead and dive into linear functions. There are two equations typically that we think of when we think of linear functions. We got our slope-intercept form, which is y equals mx plus b. It's called slope-intercept form because m is our slope and b tells us our y-intercept. And then you have your point slope form, okay? When you're given point slope form, once again, you know your slope. And then you know one point that's on your line, and that's x1 comma x2. Okay. A lot of times we start out in point slope form and move it into slope intercept form to simplify. Usually this is the quickest route to go. And then just remember when you guys graph a line, here's one example. It could look like this. This would have a positive slope. And then here's another example, something like that, if it was nice and straight, and that would have a negative slope because as I look at it from left to right, it is going downward. So example 1 says find the equation of a linear line. It's kind of redundant, isn't it? To be linear, you have to be a line, where f of 1 equals -8 and whose slope is -5. Okay, so this is pretty straightforward. We know that our slope is -5. This part right here, this is in our function notation. This is actually telling us a point. So what it's telling us is when I plug in a value of x of 1, I get out a y value of -8. So this is telling me the ordered pair 1, -8. And you'll see this quite frequently in calculus. So just remember when you input x's and you get out y values. So I have my point and I have my slope. And since I have my point and slope, I'm going to use point slope form. So the way point slope form works, it's as always y minus the y value, which is of your point, which is -8, so minus a -8, equals my slope, -5, parentheses, x minus your x value, which is 1. Then from here, I would go ahead and simplify. I'd have 1y plus 8 equals -5x plus 5. And to get y all by itself, I would subtract 8. So I have 5 minus 8, so I have -3. So here is the equation of my line for example 1.